Hey everyone, welcome back to the channel. So in today's video, we are going to discuss a very important concept of designing LLM agents, which is the memory, right? Because memory plays an integral part in designing, full-fledged agents, full-fledged LLM agents. Because without memory, LLM agent is nothing. If you just use LLM agent without any memory, it doesn't know how to remember your past message even. Let's say you put in one message, you ask one question that, hey, I am Pritam and how is the weather in New Delhi today? So it will give you the answer like, hi Pritam, the temperature in New Delhi is this, right? But in the next prompt, if you ask, in the next message, if you ask, what is my name? It will simply say, I don't know your name, because LLM by default does not come with memory. It just knows how to process the input text and generate a response for that, right? So it is quite important to integrate memory when you are designing production grade agents, LLM agents, or agentic based applications for your company or for your product. So so for that, first let's just understand what are different type of memories that an LLM can have. Okay, so if you can see my screen, by default, on a broader sense, the memory of LLM is divided into two parts. Okay, the short term memory and the long term memory. As the name itself suggests, short term means will be just considering the most recent or some latest messages or latest interactions and using those as memory, while long term memory preserves the data and preserves the conversation and the output, that facts that has been generated from a conversation. It stores on a longer term basis, right? I mean, it is not just specific to one single chat session, right? It will keep on growing and you can reuse in future chat sessions also. So first, let's discuss about short memory in brief. So short-term memory, as you can see, lets your application remember previous interaction with a single thread of conversation. It's basically session specific. I mean, you are you are asking, let's say, ChatGPT something. It is answering you things, right? So that particular session, it will preserve the memory, and based on the previous interaction, just I mean most recent interactions and most recent messages, it will try to generate a response further, right? Let's just open ChatGPT once, okay? Now, if I ask something, what is the current temperature of New Delhi, right? So this is a single chat session I'm having with the ChatGPT here, right? So it is giving some information to me, and how will be the weather tomorrow, right? See, here I have not mentioned the location, but the chat is smart enough to understand that previously I asked about New Delhi, so this message also corresponds to this message only, New Delhi only, right? If I ask this question, it will again see the weather forecast for New Delhi. It automatically assumed that the place I'm referring is here New Delhi, right? So it clearly had the knowledge about its just recent interactions. So if you just keep on asking questions, it will best assume the location as New Delhi unless and until you specify explicitly a different location. So that's what the short-term memory looks like, right? But if I open a new chat session, let's say this chat session has ended, right? If I just open a new chat, how will be the tomorrow? So it is by default, taking a random location, Bhubaneswar. Okay. So as you see, it is not taking New Delhi because the chat session has the chat session is new. So the short-term memory is not preserved across chat sessions. So now just jump back to the documentation. So if you see here, so how do we use short-term memory in our conversation is to filter some of the messages. Let's say we are having an interaction with the chatbot. This is a human message, this is the AI message. Then a list of chats and messages we are having. We are exchanging response with the chatbot. So one way to implement short-term memory is to have a filtered list. Okay, let's say you define that I will consider last 2 to 3 or last 5 messages, um, and then I'll utilize that to give the answer of the new query, right? Or give the answer of the new message. So this is one of the way you can edit the message list. You can filter the messages from the chat list and then use that chunk or list of messages as your current context to utilize it to answer your new user query. Okay, so that's how this is one way to implement short-term memory. So the second way to implement short-term memory in LangChain is LangChain or any kind of agent framework that you use. And the second way to implement short-term memory is to uh, summarize the past messages. Let's say I have a context window size of 5 messages, right? But before that, I can have n number of messages. But if I just focus on the last 5 messages, it is quite possible that I'll lose some important information which were there above that, right? For example, here I'm considering only 3 messages, but there could be some information, some useful information which are there above the context, above my current context window. So we don't want to lose this information. So what the second approach to implement short-term memory can be is ki, no doubt you take this window of message, right? Window of 3 messages as your current context. Along with that, what you can do, you can have another window, right? Let's say 10 message or the entire history, let's say, but taking entire history is not practical because the history can be long. But you can have a defined set of number of messages to utilize as your second context window, and that second context window you can pass it to LLM. Okay, so if you see clearly, we are adding LLM layer which will be summarizing the messages for us. So the entire bigger chunk of conversation will be summarized to some few lines of information now, and you can utilize that summary along with your recent 2-3 message or recent context window to generate the answer for the new user query. So this is a quite effective approach to implement short-term memory in production, because here we are preserving the information which will be there in your older conversation. So without losing those information, we are now able to respond to the user query in a much efficient manner. But in the older way, we are just simply ignoring the message, which is not what we want, right? To lose information, because information is important. So this is about the short-term memory. These are two kinds of ways to implement short-term memory. So now let's just jump to long-term memory. Okay. Now long-term memory, as I told, it's not dependent on a single chat session. Just like we see here, as soon as I click on new chat, the session is the session memory is not getting transferred to another chat session. So it's case of long-term memory. Long-term memory preserves the information from in a global state, so that it can be referenced, and the information in it can be utilized across multiple chat sessions. If you see, I am Pritham. Now if I click, see, it is storing the information in a separate memory. Okay, this is the global memory. Now this information is preserved here. Okay, if I open a new chat session, and say I am 26 years old, what it will do, it will store this fact in its memory. See, memory updated is saying, if I click on manage memory, see, this was from my previous chat and this is from my current chat. So it is preserving the information in a global state, right? So that the same can be utilized across multiple chats. Now if I ask, what is my name? It will clearly simply say your name is Pritham, because it is getting those information from this memory. But if I delete this, let's say I delete this memory and open a new chat session and ask, what is my name? It will clearly say you have not said your name with me. So you can now see the difference, how well long-term memory looks like. But it is not all. Long-term memory is actually divided into 3 types of subcategories. Actually, the 3 type of categories about long-term memory has been taken from this research paper. There is a very good research paper for cognitive architecture for language agent, where they are defining a new architecture to build LLM agents. Coming about the long-term memory, yeah. So in this research paper, they have mentioned long-term memories as episodic, semantic, and procedural. These are the 3 main categories of long-term memories. Now let's just understand what are these categories and how it is important for you to understand the difference, so that accordingly you can design your long-term memory components, okay, based on these concepts. Okay. Now as you see, a long-term memory, as we discussed, it is defined into 3 parts. It's semantic, episodic, and procedural. So let me just give you one example of each one of these. So in semantic memory, what it is like, these are the raw facts or static data which won't change. For example, if I say like, if let's say I'm a travel agent and someone asks me that what are the places to visit in, let's say Bangalore, okay? From my knowledge, I can tell them that you can visit ISKCON temple, or you can visit Rameswaram, or you can visit to Hampi, right? From Bangalore, you can take the train. So these are the raw facts which is not going to change, right? These are the popular travel places, so tourist places. So I can suggest them this information. So the facts are actually semantic memories or static data which does not generally change. Now let's discuss about the episodic memory. In episodic memory, what we do is episodic memories are linked with the previous conversation with the agent or previous interactions with the agent. Okay, for example, if someone now still I am a travel agent. Okay, if someone comes and tells me ki, hey Pritam, last time when I visited Bangalore, you had suggested me to go to ISKCON temple. Can you suggest me some more places? You had suggested me to go to ISKCON temple, and which I liked. So can you suggest me some more places to visit? So from this, I can infer that the person is liking to visit temples, right? Because ISKCON temple I had suggested, he went and he visited it and he liked it. So next, what I can based on this current information, what I can suggest him ki, yeah, now you can go to maybe Chikballapur, right? The Adi Yogi statue you can visit, because it's again related to that related to culture and all. So it's a temple also. So I can infer from it that he might be liking temple. So let me suggest a temple instead of suggesting him to go to any beach or kind of any bar or club, right? Um, so that's what episodic memory is about, right? It's based on your experience. Okay, I mean, based on your past agent actions, like whatever actions I had done in past as a travel agent, I had suggested him to go to ISKCON temple. Now, based on that information with my mind, I'm suggesting places for him. So this is about the episodic memory. So you can clearly see the difference between a semantic and episodic memory by now, I guess. Before jumping to procedural memory, let me just show you how semantic memory is in a agentic workflow. This is just a raw example I gave, but in a LLM agent point of view, let's say you are maintaining the profiles, right? You are storing the data just like ChatGPT stored my name and age. Similarly, the LLM model is storing information about me. First, I told it my name is Pritam. Next time, telling it my name is what? My age is 26. So based on this conversation, right? I am having a conversation. I have a old memory, right? I have a old state with it, right? So in the old state, now with the new information that my age is 26, what LLM can do, it can update the information in the semantic memory. Okay. So this is how the semantic memory, it's just plain fact, a static data which won't change. My name won't change, right? My name is Pritham, it won't change. So it's a static data which it can store. Now to implement semantic memory, you can utilize in-memory stores. LangChain provides in-memory stores, right? Or you can consider using any external database also, right? So that is up to you how you want to store the data. But let's just understand the concept for now. Now, if I go to episodic memory, so one popular example of episodic memory is few short example prompting. Just like I gave you that example, right? Based on some past example, I had suggested him to go to ISKCON temple. This acts as a example for me, right? This is a few, let's say one short example. I have one example with me to suggest next place to the same tourist or same user or the same tourist, right? So few short example, I'll definitely create a different video about few short example and how it is different from zero short and one short and few short examples, how they work actually, and how the output accuracy improves with few short examples. I'll create a video next in 1 or 2 days. So don't forget to check that out. So few short example is a popular example of episodic memory, okay? Because we are referring to some relevant examples, past examples, then utilizing it in the current context to respond to the user query. Now let's jump to the procedural memory. So procedural memory is kind of it's a defined set of rules, a defined set of actions, how you want to perform to get a task done, right? If you see here, by definition, it is procedural memory is nothing but the rules to perform task. Okay. So for AI agents, procedural memory is a combination of model weights, agent code, and agent's prompt. Basically, agent code we must be having, then we do prompting, right? And model weights is nothing but our LLM model that we are using. So this is about the procedural memory. I mean, it's just plain instruction. In few use cases, you might want to store the path it had taken to solve a given problem. Okay, for example, to let's say one user came to you and asked you to plan a trip to Bangalore, plan a trip to New Delhi from let's say Bhubaneswar. Okay, so to solve this user query, there are multiple steps involved. You want to design an itinerary, right? Then you want to search the cheapest flight, then search the hotels for the user, then search the places to visit which he can visit. So in order to prepare the complete itinerary, it has to solve multiple problems. So what we can do, we can store this entire procedure that it had followed, like the book flight, then search hotels, then explore places and suggest places. The output of each of these steps we can actually store in the memory, so that next time if another user comes and asks, give me a tour plan from Bhubaneswar to New Delhi for 2 days or 3 days. So what we can do, instead of regenerating the outputs again, we can utilize that memory and then refine the output a bit to match to the user query and reply to the user. So this is what the procedural memory is about. So I hope I was able to clear your concepts about episodic memory, semantic memory, and procedural memory. So all these three types of memory are actually long-term memories, which can preserve, which can be utilized across chat sessions. It is not dependent on the single chat session. So I'll suggest you to go through this research paper. If you like, I'll just put the link in the description box. And mainly this documentation of LangChain to understand about memory. It is explained in a beautiful manner about how to implement short-term memories. Okay, how to implement semantic memory, how to implement procedural memory in LangChain framework, obviously. So, but it will give you a gist of these things and its practical implementation. Anyways, we are going to implement memory in our next video. We will be doing a practical code example and integrating memory with our LLM agent, and just explore how this kind of short-term and long-term memory are actually used in practice. So that's about today's video. If you have any doubts about whatever we discussed in this video, put them in the comment section. I'll be sure to answer them. So I hope you liked this video. If you like this video, please subscribe to my channel. We are targeting to reach 2200 subscribers by the end of this month. So keep supporting. So thank you for watching this video, and I'll see you in the next one. Thank you.